Welcome to this playlist of CFA Level 1, and this is Book 1, Quantitative Methods, and we are going to touch upon the first learning module, or you can say chapter number 1, Rates and Return. And I've divided into several parts, and this is the first part, and in this particular video, we are going to touch upon two topics. One is interest rate, second one is time value of money. And these are some basic topics, foundational topics, and I am pretty sure that you are very well versed with both the topics. But we are going to see what things are there so that your conceptual clarity is much better. And I hope you'll be easily able to understand what I'm teaching. And if there is any confusion, please do comment. Right. So interest rate. So interest rate is known by different names. You can call it required rate of return, discount rate, or even opportunity cost, right? This might be a little confusing. So what I'm saying is that interest rate can be called in any one of the way, right? Which is written here. So what basically is interest rate? So if I tell you in simple way, if you do certain kind of investment in one of the investment product, you require return, right? So that return which you require is your interest rate. Or suppose if a bank gives loan, so when bank gives loan, they charge interest. So this is interest in simple way that I've described. And these interest rate, depending upon the situation or depending upon the context, can have different name. They are one and the same, but depending upon the context or situation, the interest rate can be called as required rate of return, or it could be say discount rate, or it could even be called as opportunity cost. And I'm going to give you all those contexts and situations so that you are able to differentiate why different names are given, and you yourself will be able to use these names as per the context. But before that, let's touch upon time value of money. Right. Time value of money is nothing but, if I ask you, like, is $100 today, right now, will it be equal to $100 a year after? He would definitely say no, right? There is a concept called inflation. So I'm just giving you an example to make you understand the value of time value of money. So as per inflation, suppose you are able to, for this $100, you are able to buy one chocolate. For how much? $100. A year after, 1 year later, this same chocolate, one choco, I'm just going to write, it might say cost $110. Right. So the price has increased over time. So in a one way, what I can say is that this $100 today is equals to $110 1 year after, 1 year after, right? So $100 today is equals to $110 a year after. So this is the basic concept of time value of money, which basically says that the value of money changes over time, right? It depends upon the time. Or in another way, what I can say is that this $100 today is not equals to $100 a year after. It's not equal, right? So this concept is as per time value of money. Hope that much is clear. So as for time value of money, it is also said that cash received today is preferred to cash promised in the future, because promises can be broken, right? A default may exist. Default might occur wherein a default might occur wherein the person who is promising you this money might not pay, right? So you'll always prefer to receive the cash today. So this is as per time value of money. To sum it up, what I can say is $100 today is not going to be equals to $100 a year after, or even 2 years after, or over 3 years after. The value of that same 100, the value which we have given, is going to change over time. I hope till this topic it is pretty much clear. Let's understand this also. It's just going to be a repetition. So if I tell you that 9,500 today is equals to $10,000 1 year after, right? They're equal, which means to say that 10,000 minus 9,500 is how much? $500. $500 is the required compensation. Compensation for what? Compensation because you are receiving this $10,000 in a future, right? So it's just like this. If I ask you, would you like to receive 9,500 today, or I'll give you $10,000 after 1 year? Which one will you pick? Or if I 9,500 today or 9,500 a year after. This one is 1 year after. In this part, you'll definitely say give me today, right? Because the value is same, better to receive it today. But if I ask you this question, then you at least think, you might pick this one or even this one. You'll at least think, okay, if I'm getting this after a year, I'll get additional how much? Additional $500 you're going to get, right? So you at least think before deciding. Or if I say 11,000, then it is 1,500. So when I give you such kind of choices, then you'll at least think, because in future you're getting more money. So the extra money that you are getting in this $500 is compensation. Compensation for what? For not getting the money today, but receiving the money in future, right? So this compensation is also known as, this compensation of 500 is also known as required rate of return, right? So for you to invest, or in some other way, I can say there is an investment A. There is a product called investment A. For you to invest in this investment A, I need to give you X amount of interest rate. So this X amount, you are saying if you go below this X, then I'll not invest. But if you give me at least X could be anything, right? So that if you give at least X or more, then only I'll invest in your investment A. So this requirement, the condition that this much amount of return is required, is also called as required rate of return. This is how much I require. Hope I'm clear. Right. What about discount rate? What about discount rate? Discount rate is used when, so in this case, let's see, in this case, 500 is the extra that you are getting. If you forego 9,500 today and you want this money a year after, or suppose you have invested 9,500 in my investment A, okay, and because you have invested, I have given you $10,000 a year after. So this extra $500 that you're getting is your interest. So if I calculate it, 500 is the extra money that you are getting on how much, and you have invested 9,500 and you are getting. So if you calculate it, this will come out to be 5.26%. So this is the interest rate, required rate of return. So if I ask you for this example, you say that the required rate of return is 5.26 is my X amount of required rate of return. Similarly, the discount rate. So discount rate is used in the context or in the situation where you want to know how much a future value will be valuing in present day. It's a little confusing, right? I'm trying to explain you in this in as simple word as I can. So what I mean by this is, so in this example, you'll be using discount rate only when, supposing I tell you that the interest or discount rate is 5.26 and you will be getting $10,000 after a year. Okay, for some work that you have done, or it could be anything. But the discount rate is 5.26. So in this case, using this discount rate, using this, what rate? Discount rate again. Repeating, discount rate. You will be able to, using this rate, you will be able to know the present value of, this is after 1 year. So 10,000 will be, present value will be how much? 9,500. So using this discount rate, you will be able to arrive at any value, say X value that you will be getting in future, right? So using this discount value, you will be able to tell how much this X will be today. I hope I'm pretty much clear about this. Let's talk about, opportunity cost. Opportunity cost means, suppose you had the chance to invest 9,500 today, and if you had invested, you would have received $10,000 after 1 year, and this was the compensation or interest that you would have received, and this was amounting to 5.26 interest rate, discount rate, right? This is only when this situation is only when you decided to invest this much amount today. But suppose you say, I don't want to invest 9,500 today, so you decided to spend the amount on yourself. You bought something or something for yourself or your family. So since you have not invested this in our investment aid, you decided to spend it, you have foregone an earning of how much? $500, or you can say 5.26% interest rate. So the interest rate that which you have gone is nothing but opportunity cost. So this is the opportunity that you have lost. Alright. So this 5.26% is the opportunity cost of capital, or you can say opportunity cost of current consumption. So since you have not invested, we have lost this opportunity. So this is the opportunity cost. I hope this is pretty clear. So required rate of return is also called minimum rate of return, and investor must receive to accept the investment. Otherwise, he or she will not accept. Discount rate is, in case we are getting say X amount after 3 years, and we want to know its present value today, then the rate which you will be using is called discount rate. And opportunity cost is the cost of the opportunity which you have lost. Alright. Now, I hope these interest rates are at least pretty clear to you, and we also have the basic idea of our time value of money. Now let's see what does our interest rate depends upon. So for any investment, the interest rate which a person will be receiving, or if you are the one who is creating that investment product, how much interest rate you are going to give. So it will be determined by several factors, right? So interest rate is determined by, say, money supply, money demand, okay, other factors like inflation, default risk, liquidity risk, maturity, that is short term or long term. So it might be a little confusing. I'll clear it up for you. So it depends on so many factors, basically. So let's see it one by one. Interest rate is, first of all, interest rate is determined by money supply. Let's understand it first. This one we are going to see basically. So let's see how interest rate is determined by this. So basically, suppose you have created a product called investment A, for example, or let's name it investment XYZ. So you have created this product and you are asking money from the market. Alright. Suppose condition 1, if the money supply, MS, is very high, okay, so you have many people out there with lots of money. So because there are lots of people with lots of money supply is high, they have lots of cases, it will be easy for you to get money, right? And since it is easy for you to get money or get people to invest in your XYZ product, there are lots of people. So basically, since there are lots of people, you try to give less interest rate when and if people invest in your product. In second scenario, suppose the money supply is very low. So in one way, I can say that there are very few people with money. So it will be very hard for you to get money. So to get that money, which is in very low supply, you will attract people to invest in your investment by giving high interest rate. Alright. So the interest rate is determined by money supply. So in one go, I can say that if money supply is high, the interest rate will be low. If the money supply is low, the interest rate will be high. Alright. Now, let's see money demand. Money demand. Let's talk about this one now. So in here also, there are two conditions or two situations. So you had this called investment XYZ. Okay. And similar to XYZ, some other people will also be having their own MN, P, Q, P, R. So these are different kinds of investment products. So these products, all of them are demanding money from the market. Demanding money from the market. Okay. But suppose in our market, there are only 3 products. So the money demand is only by these 3 products for in a market called A market. Okay. But money supply is constant. So money supply is, say, let's assume it is $10,000. So this is constant. Just for example, or let's make it $1 lakh. So this is constant. Money supply is constant, but it is demanded by only 3. So money demand is less. If the money demanded is less, this is condition 1. If money demanded is less, and this is constant, then interest rate will be less. Okay, I'll clear it. But if you see the second situation, money demanded is high, now it will be clear. So in our scenario, there were only 3 products, but supply is constant. But suppose XYZ, MNP, QPR, there are many thousands of investment products. There were only 3 products. Now these thousands of investment products are demanding money from the market. So these 1,000 products will have to share this $1 lakh, right? So the demand is more. So each of the different 1,000 products by different 1,000 companies will try to get money in their company. So they will be fighting with each other. So to attract money, they have to give high interest rate. Now I hope let's say. So when the money demand is low, you can easily get the cheaper interest rate. But if the money demand is high, you'll have to pay high interest rate. So basically, it all depends on money supply and money demanded, right? So the interest rate is dependent on that. So to sum it up, you don't have to remember all this. I did just very basic. I went very in depth because I am assuming that there are certain students who will want to go to the basics and want to clear their, foundation. So that's why I just explained it to you. Some of you it will be very easy. So to sum it up, what I can say is if the money supply is a lot, automatically you don't need to worry. Money is available just like that. So the interest rate will go down. But there is very less scarcity of money. Money supply is very low. Then to get that scarce resource, the interest rate has to be more to attract that scarce resource of money. Similarly, demand of money. If money is demanded like anything by every individual, every company, every firm, then they'll be fighting with each other, and to attract money, they'll have to pay higher interest rate. But if the demand is low, then they'll have to pay less interest rate. I need not even have to explain all those. So I hope this is pretty clear. Along with this, so you can say that interest rate is dependent on this too, money supply and money demand. Along with this, there are other factors like inflation. It also depends on default risk, liquidity risk, maturity. Let's see how one by one. So if there is no risk at all, so these are different kinds of factors. If considering there are no factors, then the interest rate is called real risk-free interest rate. But this is the basic form of interest rate when there are no risk in the market, nothing is there. But situations or factors such as inflation is there in the market. So inflation means because of the time value of money, I told no that one chocolate is going to cost $100. After a year, it is going to cost $110. This is because of inflation. The prices or the value of money over a period of time is going down, right? Inflation. Deflation is the reverse scenario. Deflation means here the $100 chocolate that you were buying earlier, right? In case of inflation, the same chocolate was costing $110. Deflation means $100 you're buying a chocolate today. A year after, you'll be able to buy it by say like $90. So the value of money has increased. In this case, the value of money has gone down, right? So our interest rate is also determined by inflation risk. The more the inflation, the more we have to pay interest rate to cover up that inflation. So in the real risk-free interest rate, we add something called inflation premium, right? Similarly, the default risk. Default risk is nothing but if suppose you are the one who is investing in certain firm, or if you are the one giving out money to some individual or to say someone or say some firm or company. What is the guarantee? What is the guarantee that you will get back your money, right? It might be the case that they will not pay you back money. They are not in that condition or they are not able to give you the money. So in that case, they have defaulted. So that also you have to consider, and accordingly on the real risk-free interest rate, you have to consider default risk premium as well. So you have two friends, A and B. Say A is rich, B is poor, and you give them both $100. So who has more chance of defaulting? You will say that B has more chance of defaulting. So accordingly, the default risk premium, you might be charging him like 5% interest rate. Here you will say, I will only give you money when you are able to give me an attractive interest rate. So say 10%, then only I'll give. So this extra 5% is default risk premium. Otherwise 5%, if you are only giving 5%, why should I give it to you? I will default another, say C, who is rich, 100, I not give it to you. It's the basic idea about default risk. So basically the government has several securities, right? P-bills and all that. So we believe that government will not default. So their default risk is almost negligible. And there are several firms, companies who are rated, say A-rated, B-rated, C-rated. So when you go down, the chances of default will increase. So as we go down, the interest rate given by the banks and all will also increase because of this concept called default risk premium, right? I hope I'm pretty clear about this default risk. Last one is liquidity risk. Liquidity risk, and accordingly we add liquidity risk premium. Some of them even can be zero, like default risk can be zero. Suppose you are giving loan to the government, then this default risk might be say zero. So it is not necessary that all of these factors will be considered to determine the interest rate, but they are there. So liquidity premium is like how much liquid is your investment. So for example, US T-bill, alright? So US T-bill, they do not have liquidity risk premium. They do not have this. Why? Because these T-bills, basically, these T-bills can be bought, can easily be traded, right? Traded, or you can say bought and sold in large amounts easily without affecting the market. So basically what I mean to say is that high liquidity means there are lots of buyers and sellers. Okay. Less liquidity means there are only few. Less liquidity means there are only few buyers and sellers. Right. So cash is considered to be very liquid, highly liquid, sorry. Highly liquid. Land is not easy to sell off, right? So they are less liquid. So those products which are highly liquid, their liquidity premium will be less. Those products which are less liquid or illiquid, their liquidity, I will not use the word illiquid because such a thing does not exist. So those products which are very less liquid, the liquidity premium will be high because you're not able to buy and sell it easily. Suppose you have bought that product by, say, giving some interest rate or by getting some interest rate, you'll be charged a higher liquidity premium because you will not be able to, they will not be able to easily sell it off, right? I hope I'm clear. For listing will also be added. So basically, these things are going to determine the rate of interest. Last one is the maturity, short term or long term. So if it is long term product, then maturity premium will be high. If it is short term, then maturity premium will be low. Okay? It's not decreasing actually. Maturity premium will be low. This will be, for long term, it will be high. Why so? Because maturity means when you lend for, say, longer period of time or longer period of time, when you lend for longer period of time, then you are basically taking more risk. Right. The longer you lend it for, the more risk you are taking. But if it is for very less day, then you are basically taking less risk. Right. So interest rate will be determined by all the factors: money supply, money demand, and other factors like your inflation, your default risk, liquidity premium, maturity premium, and all that. Now, there is the concept of nominal risk-free interest rate and real risk-free interest rate. So, real risk-free interest rate plus inflation. This is called nominal risk-free rate of interest rate. In some other words, I can say that this nominal risk-free interest rate is the interest rate in which inflation has been factored in. Inflation has been factored in, or inflation has been accounted for or adjusted for, right? So, real risk-free interest rate, and once you consider inflation, if you're giving loans for, say, 3-4 years, and if you know that inflation is going to be 4% or 5%, and when you adjust this inflation rate to your interest rate, then you have already considered the inflation, and the result of that interest rate would be nominal risk-free interest rate. So, basic formula is real risk-free interest rate plus you add the inflation, you get nominal risk-free interest rate. But there is another formula: 1 plus nominal risk-free interest rate is equals to 1 plus real risk-free interest rate multiplication in bracket 1 plus inflation premium. Alright, and this, if I give you an example, suppose real risk-free interest rate is, say, actually you are going to charge an interest rate of, say, 3%. Sorry. You're going to charge an interest rate of, say, 3%. but the inflation is say 5%. So because there is an inflation of 5%, so what I can say is $100 you're able to buy a chocolate. Because of inflation, the chocolate price after a year will be 105. Right, you see, a chocolate will be able to buy for 105. This is because of inflation. And as you can see, it has increased by 5. So 5 is the interest rate, right? 5 divided by 100 is into 100. It will be 5 is the inflation rate. So because there is an inflation that exists in our example of 5 rupees or 5% interest rate, when we account for it, the interest rate which you will ultimately charging is 8%. Hope I'm clear. But in this case, let's see how much will be the nominal risk-free interest rate. So if I put in the formula 1 plus 3% was the real, sorry, this is nominal, okay? So 1 plus real risk-free interest rate is how much? 3%. So I can write it like this. And inflation is how much? 5%. I can write it like this. So I can write it like this also. So if you multiply, you can use a calculator. If you multiply, it is coming out to be 1.0815. Or I can write it as 1 plus, right, 0.0815. I can write it like this, right? And this side it is 1 plus n. So nominal risk-free interest rate is this one. So n nominal risk-free is 0.0815. If I convert into percentage, it is 8.15%. So in our example, the nominal was 8% by using the first formula. Here we are getting 8.15%, right? So which formula to use? So this is approximate formula when you want to consider or calculate nominal risk-free interest rate. This setting formula is when you want the exact value. And why is it so different? Why is it different? There is a difference of 1.5%, right? It is because this formula considers compounding of money, considering real risk-free interest rate and inflation together. Here, they are being treated separately in our formula, okay? We did not go into much of the basic, but I think I gave you an overview of what it exactly means. So I just wrap it off. I hope it is pretty clear. And when we typically talk about interest rate, they are always quoted in annual terms, okay? So if you find that there is an interest rate of on 90-day common debt securities, say for example any T-bill or something like that, and they are quoted at 3%, it is always this 3% is not for 90 days. Okay, the instrument is for 90 days, but this 3% is not for 90 days. This 3% is actually annualized rate and not the interest rate on over 90 days. This you'll have to take care. So this is a very interesting question, and I'll try to explain it to you in very simple and easy way. But if you try it on your own, it might be a little challenging, not that difficult, but it will be a little challenging, because for me to understand also, it took a little bit of effort. But once you understand it, it's pretty simple. So there are total 5 investments given, as you can see, and each one has got, different features. So maturity risk for investment, say 1 day is 2 years, liquidity is high, default risk is low, and according to the interest rate is 2%. Alright, so this interest rate of say 2% for investment 1 or 2.5 for investment 2 depends on all these features, right, which I have explained to you before. So the first question is that we have to explain the difference between the interest rate offered by investment 1 and investment 2. So investment 1 is this, and investment 2 is this. So there is a difference of 2.5%, as you can see. We have to tell why is it different. Basically, if you see carefully here, both the investment, you can see that both the investment, the maturity, that is this one, is same. Default risk is also same. So had it been like this, liquidity, had this two been same, the interest rate would have been same. The difference is because these two are different, right? So as you know that if for any security, if the liquidity is low, right? If the liquidity is low, it will be more risky because you will not be able to sell it or buy that security easily. So the risk premium will be high. So accordingly, it is high by how much? 0.5%. So from this, I can say that liquidity premium, the only difference is between this. So liquidity premium The difference is almost 0.5, right? So the investment 2 has plus 0.5 here. So this difference is only because of liquidity premium. So I can very well write that liquidity premium is 0.5%. So the difference is because of the difference between the interest rate between investment 1 and investment 2 is because of this liquidity premium. Alright. So we have got one question, that is, or we have got what the liquidity premium is. Now, second question is estimate the default risk premium affecting all securities. So here we have already established what liquidity premium is. Now we have to find out default risk premium. So we'll have to see how much is the default risk premium. So to do that, we need to look at those investments. Basically, we have to just erase it off so that I can make some room for myself. So I'm not going to erase this liquidity risk premium because it does we need it. And now we have to find out default risk premium. So we'll have to find this one. So to find this one, first we have to check those investments where this default risk premium are different. So here this is low, this is high. So through this investment 4 and 5, we can try to find out the default risk premium. Because between low, we will not be able to find out because it will be same, right? So if you look at the investment, if you look at the investment 4 and 5, we are noticing something that maturity is same, the liquidity is same. The only difference is because of default risk. So this difference in the interest rate is only because of the default risk. So if the default risk is high, the default risk premium would also be high. For since investment 5 has higher default risk, this interest rate is high. And it is high by how much? 6.5 minus 4 would be 2.5. So default risk premium is, we have got our answer is 2.5%. Oh, that is clear. Now, third one is a little bit tricky, but nonetheless, I'll try to explain it to you as simple as possible. So the third problem is calculate upper lower limits of unknown interest rate for investment 3. The investment 3 is this one, and we have to find out this one. So as you can see from the question itself that it is asking us to calculate upper and lower limits. So in a way it is trying to tell us that we cannot know the exact value of R3, but we'll know the upper limit and lower limit. So let's try to find out what exactly this R3 will be. So if you compare, I'm just randomly picking up, alright. So if you compare investment 2 and investment 3, because we have to find this one out, right? So if you compare investment 2 and 3, we again notice that liquidity is same, default risk is same, right? The only difference is the maturity. So the investment 3 has got higher maturity. That means higher maturity will have more maturity risk premium. So definitely our R3 here, R3 is going to be more than 2.5. So we have got one lower limit. So R3 is going to be more than 2.5. But it will be less than how much? So this we have to find out. For that, let's again see. Just erase it off. Let's see what else we can compare. So if we compare investment 3 and investment 4, it has got same default risk, right? And maturity is different. This is different. So let's not focus on this. But let's make an assumption here. Please listen attentively. Let's make an assumption here that you can see that the liquidity is different, right? what if for a while I cut this off, or I make a assumption that this liquidity is high, alright, for investment 3. Then default risk is same, liquidity is same, right? The only difference is maturity. So investment 3 has less maturity. So since liquidity is same, default risk is same, assuming liquidity is high, okay, liquidity is same, default risk is same, the only difference is maturity. So this is investment 3 has less maturity, so less maturity risk premium. So we can say that R3, I'm writing it here, R3 will be less than 4, right? Right? If we assume the liquidity and default risk is same. But here the actual reality is that our liquidity is not same. It is actually low, right? So there will be liquidity risk premium. How much? We up to this 0.5. This is the reality. So R3 is less than 4.5. So here we can establish that R3 is less than 4.5. So this is our answer. So the R3 will lie between 2.5. It will be more than 2.5 and less than 4.5. So these are the upper and lower limit. And if you're confused, let me just once again repeat the last part. How we arrived at this, just remove everything. Alright. I hope you remember the values. So to calculate R3, we already know our lower limit. To calculate the upper limit. So for this investment 3 and 4, was it in repeating? Let's assume that this is high. So our liquidity is same for investment 3 and 4. Default risk is same. The only difference is maturity risk. So this maturity for investment 3 is less, so it will be less maturity premium. So R3 will be less than 4. So R3 will be less than 4, right? But the reality is that liquidity is not high, but it is low. So since liquidity is low, liquidity risk premium will apply, right? So we add 0.5 to it, so R3 will be less than 4.5. So this is how we got our answer, and that's it for this question.